Students, last time I have discussed about the zero order reaction. Today I am going to discuss with you first order reaction. First order reaction. Let us consider A gives product. So here we can write R is equal to K A to the power 1. Now in terms of differential equation, dA upon dt is equal to K. So here dA is equal to minus K into dt upon on integration of both sides. So here this is the dA upon A minus K dt. As you know, integration of dx over x is equal to minus ln x. Ln x, this is the log ex. So here we get minus ln x is equal to minus k into dt plus c. Students, at time t is equal to 0, you know this is the t, kb plus c. This is the a. So a is equal to a naught. This is the equation number first. On writing the value in equation first, students, we will get minus ln a naught is equal to, this is the c. So c is equal to minus ln a naught. Now on putting the value of a naught into the equation number, on putting the value of c in equation number first, on putting the value of c in equation first, what will we get? Student, we get minus ln a is equal to minus kt plus c is equal to minus ln a naught. As you know very well, this is the ln a naught minus ln a is equal to minus k into t. On taking the minus common, ln a minus ln a naught is equal to k into t. This is the first equation. So student must remember that here, you know that this is a concentration at time t, and while the a naught concentration at time t is equal to 0. Okay, so you know k into t is equal to ln a upon ln a naught. You know very well why, sir? Because log m minus log n is equal to log m upon n. So we could have no problem. Student, here k is equal to 1 upon t ln a upon ln a naught. So here k is equal to 1 upon t. When we replace the ln, multiply by 2.303. So this is the k is equal to 2.303 upon t log a upon a naught. Okay, so here this is the equation for first order reaction. Okay student, try to understand again for this step. This is the k into t is equal to ln a upon ln a naught. Clear? Here you know this is the natural log, this is the LE. So LE is equal to 2.303 log 10. So multiply by 2.303. Okay, when we multiply that, here we get the k is equal to 2.303 a log 2.303 log a upon a naught. So we put the value here 2.303 upon t log a upon a naught. So this is the equation for first order. We can also write here from this equation, as we know, k into t is equal to ln a upon ln a naught. So we also write that a upon a naught is equal to e to the power kt, or a naught upon a is equal to e to the power minus kt. So this is the derivation for the first order reaction. I think all of you understand. I am again going to describe it. See seriously, r is equal to k to the power 1. Here the a to the power 1 represent that this is the first order reaction. We know differential equation can be written as minus g upon gt is equal to k into a. Here is the a to the power 1, that is equal to the a. So d upon a is equal to minus k into dt. On integration of both sides, when we take the integration of both sides, you know dx upon x is equal to minus ln x. Okay, so it is equal to the log ex. Students, here k into dt minus ln a minus kt plus c. Student, at time t barabar 0, a is equal to a naught. So here I'll put the value of a naught in the equation first. We will get that minus ln a naught is equal to 0 plus c. C is equal to minus ln a naught. I'll put in the value in equation number first. So when we put the value minus ln a is equal to k into t plus minus log ln a naught. On taking this ln a naught on this side, we get the minus ln a naught minus ln a is equal to minus k into t. So here ln a minus ln naught is equal to k into t because this minus will move from here. Okay, so a is equal to the concentration at time t, a naught is equal to concentration at time t barabar 0. You know very well k is equal to rate constant. Okay students, so k into t is equal to ln a upon ln a naught. K is equal to 1 upon t ln a naught. You know very well, when the natural log converted into the log of the 10 to 10 base, the multiplication of 2.303 will take place. So here we get k is equal to 2.303 upon t log a upon a naught. Okay, so guys, we can also derive a small equation from the previous equation. K into t is equal to ln a upon ln a naught. You know, when we replace the ln from this side, here is the exponent will be takes place. So e is equal to k into t. Okay, so a naught upon a is equal to e to the power kt. When we reverse it, so a naught upon a is equal to e minus k into t. E kt. Clear? So this is the derivation of first order reaction. हेलो स्टूडेंट्स, तो प्रॉपर्टीज ऑफ फर्स्ट ऑर्डर रिएक्शन में सबसे सिंपल बात ये है कि हमें पता है log a इज इक्वल टू माइनस के इंटू टी अपॉन 2.303 प्लस log a नॉट. तो अगर स्टूडेंट मैं इसको ग्राफिकल रिप्रेजेंटेशन में करना चाहूँ तो इट्स वेरी सिंपल. दिस इज द y, दिस इज द mx, दिस इज द so here this is log a and this is time for t, and m is equal to minus k upon 2.303, and here the intercept is log a naught. This is the intercept. Okay students, so this is the first graph regarding to the first order reaction. Second graph we can also compare between log a naught upon a. Log a naught upon a is equal to log a naught as we know kt is equal to k into t is equal to 2.303 log a naught upon a. So log a naught upon a is equal to kt upon 2.303. Okay, so here we can take this is the y, this is the m, this is the x, and c is equal to 0. So here we obtain the graph in such a way. This is the log naught upon A, this one, and this is the T. So here we get the M is equal to K upon 2.303. Students, these are the two things. One thing I will repeat, that unit of first order reaction is calculated by mole per liter. This is not last time I have written that n minus 1, not 1 minus n, second inverse. So n is equal to 1. We will get that mole per liter 1 minus 1 second inverse. So this is the 0. So unit is the second inverse. Okay. So now I am going to define the half-life period. Half-life period of first order reaction. So try to understand half-life period of first order reaction. Okay. Half-life period of first order reaction. Half-life period for first order reaction. For first order reaction. Half-life period for first order reaction. As we know, T is equal to T half. A is equal to A naught by 2, because final concentration remains half. So student, here we can written as K is equal to 2.303 upon T log A naught upon 2. So K is equal to 2.303 T half log A naught upon A naught by 2. So we get that 2.303 T half log 2. K is equal to 0.693 upon T half. We will get that T half is equal to 0.693 upon K. So this is the relation between T half and rate constant. Okay, T half is equal to half-life. Means what is the meaning of half-life? Half-life. The meaning of half-life is that the time in which concentration of reactant remains half. This is called the half time. So here one thing should be note, that half-life is not depend on the concentration of the reactant. Half-life is not depend on the concentration of reactant. For any reaction, the half-life is not depend on the concentration of reaction. So this is complete about the first order reaction. Must remember that first order reaction generally followed by first. All the nuclear decomposition. Generally, those decomposition reaction which is related to nuclear, in such type of reaction, first order kinetics will be followed. Some hydrolysis and decomposition. Also follow first order kinetics. So student, now try to understand the examples of first order reaction. Example. First one is the CH2 double bond, CH2 plus H2 gas, platinum solid, CH3 single bond CH3 gas. Second one is the NH4NO2 on heating, and 2 gas 2H2, SO2Cl2 on heating gives SO2 plus SO2 gas plus Cl2 gas. Similarly, C12H22 plus H2O gives C6H12O6 plus C6H12O6, hydrolysis of KCl. Similarly, CH3COO C2H5 mixed with water, you will get CH3COO plus C2H5OH. So these are the example of first order reaction. You can also write another example. N2O5 gas on heating gives N2O 2NO plus 2NO plus O2 plus 3O2NO, which is the 3O2NA, 3O2 and 3O2NA means O2. Okay, so we can illustrate these all reactions. Okay, with the help of these are the all examples of first order reaction. Okay, so now I am also completing the first order reaction according to the NCERT. Okay, students. In the same way, I am going to define the second order reaction. Second order reaction. Okay, so you know 2A is equal to product. We can write R is equal to A to power 2. Okay, so students, here we can write that minus dA upon dt is equal to K A to the power 2. You know, same minus dA upon A to power 2 is equal to K into dt. Okay, so here we know very well that on integrating of both sides, integration of both sides, we will get dA A is equal to minus K into D. So what will we get? We will get that 1 upon A is equal to minus K into T plus C. So same. We know T is equal to 0. So A is equal to A naught. Okay. On writing the equation, on writing the value, what will we get? We will get that 1 upon A naught is equal to C. This is the equation number first. On putting the value of C in equation first, what will we get? We will get that 1 upon A is equal to minus KT plus 1 upon A naught. It means here we get that the 1 upon A minus 1 upon A naught is equal to K into T. So this is the equation for the second order reaction. Okay, half-life of second order reaction, half-life of second order reaction. How can we calculate half-life of second order reaction? Here this is the T is equal to T half and A is equal to A naught by 2. On putting the value, 1 upon A is equal to minus A is 1 upon A naught upon 2. So this is the 2 upon A naught is equal to 1 upon A naught is equal to K into T. So A naught is common, so this is the 1 upon A naught. 1 upon A naught is equal to K into T. So this is the half-life for second order reaction. Okay, and now I think there is no doubt to you. We can write it T half. So we can write T half is equal to T T half is equal to K into T half is equal to 1 upon K into N. Okay. Now we can also write the example of second order reaction. Very simple example. First one is the CH3COO C2H5 plus NaOH. What we get? CH3COO Na plus C2H5OH. Second one is the 2NO2 gives 2NO plus O2. 2NO plus O2. Similarly, 2O3 gives 3O2. Okay. So these are the example of second order reaction. Must remember that this is not in your syllabus. Okay. So now we have also completed the second order reaction. I think all of you understand. Similar way we can calculate the third order reaction and much more.